Oh, I am back.
Hello.
Hello. Let me see very quick something here. Oh, I am back.
Hello.
Wait, hello. Let me see. Give me 1 sec. Awesome. Okay.
Yeah.
Let me see what is being shared on the screen right now. Oh, let me stop. Wait, did my screen stop sharing? It did, right? Okay. Yeah, yeah. Mine did. Mine did. Gotta be very, very sure. Also, those joining in this stream, welcome everyone. Hope everyone's having a great Saturday so far. Everyone's doing well.
I'm so excited again. And last week.
We're so excited again. Yes, yes.
Oh,
Thank you.
by the way, I am not alone.
Oh, I'm sorry.
I am not alone. I and my lucky bear are
Oh.
here.
Oh yes, yes. You have a special guest with you. Yes, today.
Yeah, of course. You know, our bootcamp series love problems, and so I'm my lucky bear.
Yes, the good luck bear. Yes, we only can have good vibes, good energy here. Yes, that's
Yeah.
love that too. I came prepared with mine too. I mean, I have mine just like prepared, same right here. We gotta have best
Yeah,
energy. Hmm. Yes, yes, yes.
absolutely.
Just like do those over here. Uh, yes. Yeah, so hello everyone in the stream. Yes, we're getting some comments that they like your bear and whatnot. Yes, we're ready to learn deeply. Yes, part three of learning deeply. Yes, yes. We'll be starting in a few minutes here. Yes, and this time we'll be learning deep learning in Java, right? We're Java only for this, right?
No,
Oh,
no,
oh, no,
Java
no, no,
lover.
no Java. Oh,
Of
uh,
course, of course, we can use Java, but first language is Python, you know. And and again, I know you love Java. I know.
yes, I'm a what they call, yeah, a Java enthusiast.
You're
It's
perfect,
okay.
yeah.
Yes, but the future of AI is in Java, right? Future.
No, use, but not first.
Hmm. That's okay. That's okay. For Python is good for AI and whatnot. So we'll give it
Best, yeah.
Python. Yeah.
C plus plus, another language. It
Mm,
doesn't matter actually, but
mm.
yeah,
But most people like just because
most
like the
popular,
language.
yeah.
Mm,
Yeah, true.
mm-hmm. And I know there's so many libraries and whatnot that come with Python and whatnot that makes it easy to use. So
Yeah, first week, even first week we saw most popular Python library, NumPy, Pandas,
right, like
Scikit-learn,
what you
Matplotlib,
mentioned.
TensorFlow, and Keras.
Mm-hmm.
Most popular for
Mm,
AI
for AI.
and data.
Mm, yes, yes, NumPy and those we don't have those in Java, I believe. So we're a little lacking in that area, but it's all good. Yes, there's some people here saying people are looking forward to part three. People are looking forward to it. Yes, yes. Welcome to those joining the stream. We're about to start in a few minutes.
One minute, please, because I forgot my water. Okay,
Okay. Yeah. No worries.
only 1 minute.
You're good. Gabby, you did not see Azar praise Python. That was, you know, we this is no one, don't worry about that, Gabby. It's I didn't, I just gave it some credit, but Java's forever supreme. Python can't. I did used to do Python in high school, but that's besides the point. I'm a reformed change man now, so yeah, part three about to be fire. But you know, one day, trust me, guys. One day we will be doing. I promise for the DSE community, um, deep learning in Java, but ERM is the goat, and we do it in Python. Yes. Sofiane, learning Java and Python in class right now. Java. There's pros and cons with honestly Python and Java. Some people say Python's easier. Some people say Java is easier. Um, Java is nice. Yeah, it really depends. Yeah, even depending what you learn first and whatnot. Um, yeah.
Learn Java first.
Yeah, I learned Java way first. So in high school, I had to learn Java, and then FIU they teach Java, and yeah, so it's a lot of Java in our university. You really can't run from it. You can't really escape it, but still it's nice. Yeah, no, it's so good, Sophia, and like it really depends. It really depends on the person whether you Java or Python. But, yeah. Um, it really does depend on what your use cases and whatnot. Yeah. Um, I think Irem, if you're all ready and all good to go, are you ready to start? All good?
Yes, I'm ready.
All right. Perfect. Let's go. Well, welcome everyone. Welcome to our last session of our Deep Learning Bootcamp series, everyone. Welcome. It's so great to have everyone here. My name is Azar, and I am a tech lead at DSC FIU. And joined by me here, and the one leading the workshop is no other than the brilliant and amazing Irem Kormurchu, teaching the last session of the Deep Learning Bootcamp 3rd edition, Zero to Hero. Yes, Irem, you can go ahead and you can
Yeah.
take it away and enlighten us with learning deeply.
Yes. Hello everyone. I am so excited again, and I am not alone because today I have a guest. And again, hello everyone. Last Deep Learning Bootcamp week, and I'm really so excited. Thank you, the SCFIU team and dear listener. I hope this week will be good, and maybe last week listeners know we had many problems, and I think really our bootcamp series love problems, really I think, and I hope we don't have these problems again. And I think you know me, but we have who attend only this week. So quickly, I introduce myself. I am Miran, and I'm computer engineer, and I interested in deep learning and especially computer vision. And I work with Google Developer Group and Women Tech Makers and DSC teams for a long time. And currently, I am organizer in Google Developer Group Istanbul and Women Tech Makers Istanbul team. And if you wanna connect with me or wanna question or detail for me, please visit my website and you can see my website URL address. And you can see here. I wait your question and suggestions. Okay. We can start. Let's start with object detection first and then look at the segmentation example. First 2 weeks, we saw this baseline model, and actually we created a base for practice. What did we see in the first 2 weeks? And quickly, let's remember. First, deep learning based on features, optimizers, loss functions, various functions, deep learning frameworks, many code examples, metrics, and more. And today, we will see real example, and especially we will see computer vision problems, solved, and examples. Usually come to me many questions for object detection and segmentation subject. So I created suggestion for data sets, pre-trained models, and more in object detection. And I want to tell a real project. So today I will show an example of segmentation with code. And people support the topics we have seen in the first 2 weeks with a real project. First stage, we split our data and we saw it previous week. And of course, we must make these steps. Data visualization of the splits, and we need the splits for our data. And then again, a previous week, we saw training process, and especially we have seen the process and the functions we use until the training stage. And today we will see a project from start to finish. And I think it feels so good for you. Yeah, firstly, start with object detection logic. And I said that I have so question for this topic. I think firstly, you will come across two approaches for object detection. Two-step object detection and one-step object detection. And in the next slides, we will see the use of these approaches in different algorithms. But let's introduce quickly this. And there are many models and algorithms used for object detection. Pretty famous algorithms, and basically they use these approaches for object detection. Metrics such as speed, accuracy, time are compared with each other is so important for choose and for these approaches. Two-step object detection first identifies bounding boxes that could potentially contain objects. So then includes algorithms that classify each bounding boxes separately, and these algorithms are known to outperform their one-step object detection similarly, but are slower in comparison. So, and slide has example for one-step object detection and two-step object detection. And with the need for real-time object detection, many one-step object detection architectures. And these algorithms, these architectures have been proposed, such as YOLO version 2, 3, SST, RetinaNet, and etc. And we try to combine the detection and classification steps, and it's so important. And other, by the way, we will see YOLO and other algorithm in the following slides. But I must say that algorithms such as YOLO and SST are the forefront with speed. And because they use one-step object detection approaches, so one-step object detection approaches most popular and most useful other two-step object detection. And machine learning and deep learning based object detection approaches. We said in the previous slides that there are many algorithms and models, and actually you see these algorithms here right now. And these algorithms are compared with metrics such as their content, speed, accuracy, and more. And we will see, we will compare some of these algorithms in future slides. Here, I wanted to separate these algorithms as machine learning and deep learning based, and of course, we mostly use deep learning based approaches. And I think many people have heard these object detection algorithms like RCNN, facial RCNN, YOLO, SSD, and other, because so popular deep learning based object detection and object detection process for so popular. And these algorithms are different from each other, and processing, data format, shapes, speed, and more. And we will look into the details in the next slides. And object detection frameworks and models and OpenCV. We saw in first week OpenCV. Maybe you remember OpenCV is most popular for computer vision area and so popular image processing. And there are many algorithms specific to OpenCV that are frequently used for object detection. With OpenCV 2.4 version, many developments on the deep learning side begin to be included, and importing models created with different libraries for image classification and creating different classifier networks and creating models, etc. So it's so important. And actually, it's detailed, but I want to say that with the OpenCV 3.3 version, an almost final distribution was created, and support is provided for frameworks such as Copy, TensorFlow, Torch, Darknet, and more. And OpenCV version was so important for us. And now let's look at the API model and algorithms used in the object detection, respectively, and these notes for next slides. First, TensorFlow object detection API, and again, so popular. First, we can say that it is a tool allows us the pre-trained models offered by Google for object detection. And these models are trained with the COCO datasets and recognize 80 objects that we encounter a lot in daily life. So it's so important datasets. It's COCO datasets. And object detection API can be easily downloaded and used by integrating our models easily. And again, it's so important for developer, for researcher. And on this slide, TensorFlow object detection, COCO datasets and its objects can be seen in here in right. And I think it's quite a lot and useful, and I recommend this for you for beginners and other process, of course. Another faster RCNN. Faster RCNN in this method, it first applies convolution neural network to the image as in faster RCNN and creates as a feature map. And we saw CNN models previous week, and from this point on, the change begins according to fast RCNN. It does not participate in region selection, but performs selective search, creating a separate region suggestion network. The remainder is almost similar fast RCNN. Faster RCNN is so similar. And here, with the time earned from the regional offer, we can reduce the forecast time to about 0.3 seconds. And criticism for faster RCNN. First, the algorithm requires many passes from a single image to remove all objects. And second criticism, since there are different systems running one after the other, the feature performance of the system depends on the performance of the previous system. So RCNN, then faster RCNN, and after, and finally faster RCNN, and speed and more and other good perform. Yeah. And YOLO, again, so popular object detection algorithm. And yeah, I can say that the YOLO algorithm is famous for its speed. The reason why the YOLO algorithm is so fast, is that it can predict the class and coordinates of all objects in the picture by passing the picture through the neural networks at one. So you can see here boxes and all objects are here. And that is the basis of the estimation, the picture by, and the basis of this estimation process lies in the fact that it treats object detection as a single regression problem. And each grid is responsible for finding out whether there is an object in the area, and if its midpoint is in it, and if its midpoint is in it is length, height, and what class it is. And accordingly, YOLO creates as separate prediction vector for each grid. And so YOLO is so speed and so famous for its speed. Yeah, it's hard. And actually, this is a comparison chart, and I get it from an article, and the source of the article is here. Of course, reference, and of course, these results many vary depending on the data sets, hardware, and operation, and more. And I wanted to include this table for general comparison. Yeah, and algorithms like YOLO, RCNN, faster RCNN are often compared to speed, and we see that YOLO is more prominent than other algorithms, especially in terms of speed. And you can see YOLO speeds and difference. And SSD, single shot detector. SSD strikes a good balance between speed and accuracy. Its balance is so important for object detection, speed and accuracy, and SSD between speed and accuracy. The SSD runs a convolutional mesh only once on the input image and computes a feature map. The whole process runs at 7 frames per second, and SSD speeds up process by eliminating the need for a Regen proposal network. And to reduce precision, the SSD implements several improvements, include and multi-scale features and default boxes. And it's important algorithm, and because I said that SSD strikes a good balance between speed and accuracy. And it's so important to terms, speed and accuracy. And RetinaNet. It was created by improving existing single stage object detection models, and such as YOLO and SSD. And RetinaNet uses ResNet as its training model. And RetinaNet can be used on the datasets with the Keras RetinaNet package, and which offer an easy to understand inference. And it's source, and you can find these models. And COCO, object detection dataset, COCO, Kitty, Pascal Walk, and more. COCO is first, so has 1.5 million object, has 1.5 million object instance for 80 object categories. And COCO is so important and so useful data sets for object detection. And COCO is also used in the following 5 fields, not on object detection: K-point detection, panoptic segmentation, sub-segmentation, image captioning, and more, not only object detection. And COCO is really so important and so useful data set. And COCO stores annotations in the JSON file, and you can see here, and the detail of bounding boxes are also contained within this JSON formatted file. And the COCO datasets use JSON formatted, and so it's so important. And Kitty is autonomous driving datasets, and Pascal Walk provides a standard image datasets for object detection. And when we look at the differences between Pascal Walk and COCO, because so important and so famous, COCO and Pascal Walk, so I want to say that these differences. First, Pascal Walk, when working with XML file, and COCO, it works with JSON file. And in Pascal Walk, we create a file for each image in the data sets. And COCO, we have a file for each of the training, testing, and validation. And bounding boxes have different formats for COCO and Pascal Walk. In the subjects of object detection, it is one of the generally mentioned data sets, and therefore it was wanted to be included in the data sets section. And reader face dataset is a face detection comparison datasets, and I wanna put that, maybe you use this. And yes, now we come to a real project and real example sites, finally. Object detection, datasets, algorithms, models is done. And now we talk about real segmentation example and real segmentation process. Together, we will examine a segmentation example from start to finish. And I cannot try right now because we don't have enough time and we are not in same class together, unfortunately. So let's examine the segmentation example together. And if you want to access this code string, the GitHub address is here. You can see here. And multi-classes and binary segmentation examples are included in the code. And In this example, the commit data set is used, and the commit data sets consists of 6 classes and is a data set containing parts from daily life. And in this example, we will do a segmentation with the commit data sets, and yeah, segmentation is a pixel-based operation. Maybe remember, bounding boxes and box is so important for object detection, and we say that, and segmentation and pixel-based operation is so important for segmentation. Box are important for object detection, and pixel-based operation for segmentation is so important. And it can be described as dividing an image into meaningful regions in which different features are kept. And the quality of the segmentation process is also related to image quality, and so important, image quality. And the segmentation results varies depending on the number of bands, image resolution, and complexity of the image, and more. And first, for this example, for our segmentation example, first the library import operations should be performed. And let's quickly explain the purpose of using libraries. And first, we covered the Keras library in detail last week. And actually, our base library used here is Keras. Keras is our base library, and we saw it previous week. And OS library used for the file paths and operations inside hardware, and one of the important libraries for system. And OpenCV, CV2 OpenCV, mainly used for image processing and various image processing operations, and processing on our image, preprocessing operations, varied changes made on color channels, and can be done with the OpenCV library, and so easy with OpenCV library for image processing operation. And the matplate library is used for plotting and visualizing process. And we have explained some libraries to use for these operations. And now let's move on to actual operations, and we will see the complete code, and we will do an segmentation operations. First, data and data paths, and dataset introduction in code. We actually learned the use of this example last week, and we divide our data set into 3 parts: validation, test, and train data sets. Firstly, train data sets is the basic data sets where our training process takes place, and we generally use 70% of our data sets here, and we reserve 30% of our data for testing and validation, 30% and 70%. And the test data set is definitely not included in the training process, and validation data sets also performs a validation during the train, and allows us to give more accurate results of metrics value during training process. And it's in this code, the main image width X, max width Y, and image for train, mask for train, image for validation, and mask for validation. And pixels are so important for us in object and segmentation operations. And we will see next slides. First, data visualize and preprocessing. So important. And we talk about how important it is to understand data. The better we understand our data, the better result we will get. And if we understand our data well and act as our data wants, our results will be good. And if there is a problem with our data, and if we want to shape data, and if you want to convert the data into a good form that the computer can read, we can use preprocessing. And if we interpret the code a bit, we actually read data first, and then we make change into line with needs of our data. And OpenCV is a suitable library for preprocessing. And in particular, we can do image processing with the OpenCV library in the most comfortable way for image processing and OpenCV. And we will make changing color spaces, smoothing image, image thresholding, geometric transformations of image, and more use OpenCV, and so important library for pre-processing for image and image processing process. OpenCV. And data loader fast. We have data here image, and we introduce the data with its path, and but we need to introduce how to get the data and how to process its data. And so we need to show the computer how to see the data. And here we do this using sequential function. And we give the value of bed size or other hyperparameters, and we need to show how these hyperparameters will be used with our data. And we do this in the data loader phase, and the quality of the data loader part generally improves our results. And so it's so important for phase for our data and quality and our results. And other step, visualize after data load. We load the data in that data loader, and after we visualize. And first visualize for us. Of course, this part is not required. And in this part, we actually make a check. And after loading our data to the data loader, we check whether it can be seen without any problems. And we do visualize process with the Maplet library, and we call our data with the dataset function, and we gave the image, mask, and the classes we want as input. And class input is car and pedestrian, and you can see now car mask, sky mask, backgrounds, and other. And data augmentation was, I think, so important for us. In this part, we increase the data artificially, and we may have various reasons for the data augmentation process. Deep learning models often need a lot of data to be trained properly, and it is often usually to generate more data from existing data using data augmentation techniques. And many techniques can be used to augment data artificially, and we have many different libraries for data augmentation. And one of them is augmentation library, augmentation, and for example, and now you are seeing screen and here horizontal flip, shift scale rotate, path if needed, random crop, perspective, and more. And it is data augmentation. Depending on the data you use, and according to your transaction and according to your data count, and you can use augmentation according to your needs and choose the right techniques. So important, right techniques and your needs. And again, visualizing. Here we see data augmentation, visualizing after augmentation. We saw visualizing first after data ladder. Yeah. And then second, we see data augmentation visualizing after augmentation technique. And we did the visualize process first after data loader, and secondly, we visualize the augmentation process in here. We had data in a new way in the augmentation process. And so again, we do visualize to check our data. And almost the same as the first visualize, the only difference is inside the datasets function, and it's here. And then we got our print source nicely, and you can see in below an image, car mask, sky mask, and background mask. And hyperparameter. The available hyperparameter may differ depending on the hardware on which the study will be performed. And hyperparameters directly affects the performance of the created training and can be run depending on the hardware. So batch size, backbone, optimizer, learning rate can be given as example of hyperparameter values. For example, we have given efficientNet B3 as the backbone value here, and there are also different versions of efficientNet. And 8 is given as the batch size value. And of course, you can choose different batch size values and parameters such as number of data and processing length, power of your computer are important when determining batch size value. And we are doing binary classification here. So even we have 6 classes in our data sets, commit data sets, and we want a single class to be segmented. So we just wrote current here in classes value. And the learning rate value is also one of important parameters for the optimizers. We also gave our learning rate values, and then we gave 40 as the epoch value, and we expect it to train in 40 steps. And here you should give the optimal epoch value, and it's hyperparameter one example. And second example for hyperparameter, we keep giving hyperparameter again, and we need to give an activation function. And you can see here, actually it's one choice, sigmoids or softmax. We think that all hyperparameters are mathematical formulas, and we need to give the most appreciate hyperparameters. And here, our segmentation operations can be multi-class or binary. And we wanted an activation to be determined according to the class value we gave here. And we choose UNet model, and UNet model especially so famous for model for segmentation process, and model selection very clearly affects our results, and therefore model selection is very important. And UNet is our model in this example. And then we choose UNet as the model and gave the backbone values and number of classes and activation function, and then modern time for me. 1 minute. Yes, I am ready. And hyperparameter 3 fast. Here, we actually continue new hyperparameters and compile the hyperparameters we give. And we talked about how important the loss function is in the past week, previous week. And especially the loss function is used with the optimizer. And each epoch value is refreshed depending on the loss function. And we try to get a better result with each epoch value, and usually our results go up. And here, two different loss functions are combined and used, and a function called total loss function is created. You can see here total loss function, and dice loss and focal loss plus and mathematical formulas. And finally, we have a total loss for loss function for training. And metrics, we give our metric value in the metric variables, and we saw the metric value in detail last week. And in the evaluation phase, metric values are very important in measuring the quality of our model, of our training process, and metrics value for quality of our model and training process measuring. And here we give the IRU score and F1 score metric values, and we are doing a compile phase and optimizer loss function and metrics value, and here and compile. And data sets and data loader, train data sets, validation data sets, and process. If you remember, we introduced our validation and train data sets, and we also wrote to data loader in the previous slides, and where we specified how to receive and process our data sets. And we give our train and validation data sets to the data loader here. And as you can see, the image and mask are here. And And our class was only only one class. And we wrote functions for augmentation and preprocessing. And here we have written this function to apply to our data. And now our data is ready for training after data sets and data loader. And callback function is so useful function. It is part that helps us during the training process. We can give our request and in callback and then make our work easier. For example, frequently functions such as early stopping, model checkpoint, tensor board can help us. And if we want to see our results simultaneously during the train phase, and we can use TensorBoard. And TensorBoard visualize our results and allows us to see our model and helps us. And it must be different inside the callback function and another or with the model checkpoint function, for example. And we see here, we can record the steps and checkpoint them while the train process is taking place. And for example, here we want our model named best model to be saved. And we write these operations into checkpoint function, and we will use this checkpoint function in the train process with the fit generator function. And it's a function that usually makes our work easier, and I recommend you to choose it. And my voice tired. And famous training fast. Yes, finally we came train fast. We have a data training process, and the most important phase of the training process, again, here we are training the train and validation data sets with the hyperparameters values, and we have given. And then the training starts with the hyperparameter values, and we give, and the training is as much as the number of epochs we have determined. And let's quickly comment the codes. And if you remember, we have uploaded our train data sets and validation data sets, the data loader fast. And we had variables named train data loader and validation data loader. And you can see here, train data loader and validation data loader. And we also introduced our callback function in the previous slides. And here we also enter our callback variable. And you can see here. And above many variables that are actually here. And below, you can see the outputs after the training process has started. And these results are right on the screen after each epoch. And the results also include the accuracy of the metrics values we give. And we gave 40 as the epoch number. And here we see the sequence of epochs over 40 epochs. And this stage is usually a time-consuming one. And here is the number of our data, our epoch account, step count, and the size of our data is very important in terms of time. Training phase and time. So important, and so important only. pilot and metric graphic. Remember, we use a history variable during the training phase, and we are using the history variable here with pilot function, and we imported the matplotlib function, and we said that we use the matplotlib function in our visualizing and driving processes. And it's hard to read the results during the training phase, and I think it's so hard. So we need the pilot and metric graphic, and actually a result is listed for each training this phase. Yeah, we saw that here, and it's hard. It's severe hard. And let's say we didn't make a list with TensorBoard, then we can pilot a graph with a variable and see the results. And I always suggest you visualize graph the results, and it will be beneficial for you to visualize the results, but when presenting your work and interpreting the results. And that's why I recommend these models and function. And I wanted to put the big version of the charts we drew with the pilot here. And it was a little small on the previous slide, 1 minute. Yeah, and we see the chart graph of IOU score and loss value score, and first IOU score and other loss function. And I said that we are using two data sets during the training process, validation and train. You see that validation with validation data set is not the same as train. Similar, but not same. You can see here. And blue is train metric, and orange is validation metric value. And 40 epochs, you can see here again, 40 epochs have been processed, and the accuracy with the validation data sets is lower than the results of the train data sets. And you can see in slides, and as you can see, again, we need validation data sets as validation with train data sets does not give the best results. And so we use train data sets, and we recommended using validation data sets. You can see difference. And model evaluation. In this phase, we use the test data sets, and this part is important to us. We had a result with train and validation data sets, and we plotted the results, and we saw previous slides. And this evolution phase is different from train and validation data sets. Why? This time it is done with the test data sets, and our model sees the test data sets set for the first time see in test data set. And we can think like this. Please imagine that someone are teaching you something. For example, many hard handwriting numbers made with different drawings. And after a while, you can learn these handwriting numbers, but how do you test if you have learned it well? And you can test it with the numbers you will see for the first time. Or another example, we all take exams, for example, math exams, and exams are studied with examples given by teachers, and but the same subjects, different and first time we see a question comes up. That's why we do evolution with the test data sets, and our model first see in the test data sets in evolution phase. And quickly, let's interpret the code on the screen in a little. We introduce our test data sets to the data generator, and we did the same for the train and validation data sets, you remember, but we did it before train process. Then we add the best model, we obtain it after the train process here, and best model is added here. Then we call the evaluate generator function and feed it to test data loader, and then we list a metric, and our three metric values are listed here. Loss function, mean IOE score, and mean F1 score matrix value. And yeah, these are most accurate results for us here. And you can see that the results we get are different from the evolution with validation and train process. And model evaluation phase, and it's finally we did evolution, we got numerical results, but we don't know how the prediction are after these operations and these values. And in this part, we make a visual prediction, and it's the last step for our code. Let's take a look at the code with the visualize function, and we list the prediction results for the random 5 image. You can see the output below: main image, ground truth mask, after prediction mask. And we can see the results by comparing the prediction mask and ground truth mask. And I think the results look pretty good. Here are the others of the results, and I want to give the results for different image as well. And I think this is the best part after a model training. And maybe you do hours of training and then you see good results. And I think it's pretty cool time, I think. And I think, again, our results look good. Again, image, ground truth mask, and prediction mask, and it looks good. It's done. Thank you, everyone. I hope you found good this presentation. I don't know why, but my voice tired. I don't know why, really. We finished our boot camp, and 3 week was so busy, and I hope everyone liked it. For 3 weeks, we saw the basics of deep learning and use with frameworks, and they are used in real projects. And I want to convert this presentation to tutorial, and I think it will be good resource. And if you have any question, any suggestion, any comments, please connect with me. And my website has all my social media accounts, and all my professional blog is here in my website. You can see here in this URL address. And thank you for everything, DSC Florida team. Sorry. Yeah. And really, I work with a super team and understandable team. And again, thank you, amazing team. And yeah, it's done.
Yes. No, thank you so much, Yuram, for oh, mine's over there. But thank you so much for giving this series to everyone who, for providing such amazing instructional content for those wanting to get into AI. You really have taught us from the really, really basics on how to get started and to actually being able to actionably create our projects as well in just a matter of 3 weeks, which is simply amazing. Every session has been super informative and very fun to watch, and it's been perfect. So from
And
behalf of the DSCFIU family, thank you so much for this amazing workshop series. Like,
thank you.
yeah. Yes, and I know the people in the chat have been saying thank you as well. You have been inspiring quite
Yeah,
people in the chat as well, and I know in the DSCFIU community on the Discord and whatnot, you have everyone has been saying how much they love learning along with you each week. So we may have had a few setbacks along the way, but that's okay because we've had an amazing experience so far, and yeah, yeah, it's been amazing. So thank you so much.
yeah.
Thank you
Thank you
everyone as
too.
well. Yes, of course, and as well, definitely want to thank everyone who has joined us for this series up to this point, for tuning in each week, and for learning alongside with us. We hope you've enjoyed the series and that you keep on going in your journeys into AI, machine learning, and and keep learning more because there's never enough to learn. So keep at it, everyone, and thank you all so much. Yes. Let